Welcome back. So we're continuing our videos on the sine function. We've looked at changing the amplitude, we looked at changing the period, which another word for change will be dilation by contracting or expanding. We're now moving into the translating part. So we're looking at translating vertically first. So when we're looking at the functions, we know that we need to translate a function vertically when we have a value for d. So right now we have y is equal to sine x down below. And what it tells us here is that I don't have anything behind the sine x, so therefore I'm starting from the origin. However, this here also, and we'll write here, is also changes the principal axis. So right now the principal axis is at 0, so everything is starting from 0, the amplitudes move up and down from 0, and we go through our x-axis on that 0. But if we change the value here, and we put d here, whatever we have for d, that's going to change where on the y-intercept I start from. I won't be changing the period, I won't be changing the amplitude, but the position that the amplitude reaches on the y-axis will change and reflect to what we're doing here. So for instance, if I have y is equal to sine x plus 2, well that means here that I'm going to be moving my principal axis up to 2. Okay, so I'm starting from 2 here now. Now, let's get a little dotted line and say, well, this here is going to be your new principal axis. So I'm going to put my principal axis here. Let's try that again. Threw our pen everywhere. So if we put a dotted line, if I can get this nice and straight. I now have a new principal axis. And all I'm doing here is everything here will now change up. So my starting point is here, my next intercept will be here, and I will finish here. The only difference I'm doing here now is that instead of coming down below here, I'm coming down 1 and I'm going up 1. So therefore, my amplitude is still 1 because I have no other value except for 1 there. So I'm going to start at 2. I'm going to have a turning point at 3 and a maximum at 3 and a minimum at 1. So I'm now just drawing my graph points. And the graph looks exactly the same. All that's happened is I've just translated this graph into a different position. Now, if I had, for instance, and let's do a different color now, just say I had y is equal to sine x minus 2. Well, I'm doing the same thing. I'm just going to come down here, put minus 2, and I'd have minus 3. And just like before, I'm going to be starting from here. I'm going to be coming up to 1. I am going to put, let me just put my dotted line, I'm going to freehand this one. Okay, I come through the x-axis, I drop down at -3 for the y, and I come back up to 2. So now I can just sketch this, and again, it's exactly the same, and the curves don't look perfect, but they're exactly the same, but just in different positions. And I can change this around. If I had negative, say I had -2, then I'd start down the bottom and come back up. But the whole idea here is that when we're doing a vertical translation, we know that some things happen. So the y-intercept changes. And that's because we're changing the principal axes. If we don't have any changes to our amplitude or our period, then everything else stays the same. So the only thing that will change in this case here would be the y-intercepts and the max and min turning points. Apart from that, nothing else changes. So when we're translating vertically, it's the d value or the d component in the equation that changes it up or down. All right, see you for the next one.